viewers, welcome to my channel. If today is your first time, please consider subscribing, share and like the video. Okay, so today we are going to look at rate of change. This is a subtopic about differentiation, and we've solved so many problems already. So if you are someone that find my videos interesting, please consider to subscribe. Okay, so as we do it always, I don't just come and solve problems just like this. I want us to grasp the basic concept. Okay, and once we get that, then we can just flow with the problems. Okay, so when we talk of a rate of change in general, that has to do with time. In general, if we say the rate of change of volume, it means that dV over dt. The rate of change of radius, it means dr over dt. But let's say we have some quantity y, which depends and varies directly with x, y, which depends and varies directly with x. That means the rate of change of y with respect to x can be written as dy over dx. Okay, but if y, the rate of change of y with respect to x is not mentioned, or with respect to any other quantity, it is just the rate of change of y, it means it's going to be dy over dt. That's one thing I want us to establish. Now, if the rate of change of y increases with respect to x, it means your dy over dx has to be positive. If the rate of change of y with respect to x is decreasing, it means your dy over dx has to be negative for that particular value. And in most cases, when we solve the rate of change problems, we have one formula we use, and that's the chain rule, okay, which says that dy over dx must equals to dy over du multiplied by du over, let's say, dt. Okay, so it means t has to be, or u has to be a function of t, and y has to be a function of u. That means there should be a relationship between y and u. Okay, so let's just say if we are talking of area of a circle. Area of a circle, we know, is a equals to pi r square. So we know there is a relationship between the radius and the area, and that connected them together. Okay, that connect them together, which is a equals to pi r square. So if there is any rate of change of a, the area, with respect to the radius, that means it's going to be dA over dr. Okay, now we just need to know this formula, and these letters I just put them there. Okay, assuming if one depends on the other, if u depends on t, or if u is a function of t, and here if, and this one if y is a function of u. Okay, so now that we've gotten the basics, I guess when we solve problems, that's the best way we can understand much better. Okay, so now let's look at the first problem, the first example here. It says that a circular ink bolt has a radius of 2 centimeters. Okay, so let's collect data here. It's key. So we have the radius, which represents as r, 2 centimeters. Okay, a circular, that's one thing again we should know. A circular, so we are talking of a circle. Ink bolt has a radius of 2 centimeters. At what rate is the area increasing with respect to the radius? At what rate? At what rate is the area increasing with respect to the radius? So now the area is increasing with respect to the radius. It means dA over dr is what we need. That's the rate at which the area is increasing with respect to the radius. Now we have to go back to the question and try to interpret. Now it says a circular ink, so we are talking of a circle. And we know that area of a circle, area of a area of a circle is equals to pi r square. Okay, that's one thing we all know. Okay, area of a circle is that. Now, if area is increasing with respect to r, so it means if a equals to pi r square, we have to find what is the a over the r. So that means the differentiating dA over the r must equals to this. Remember, we are differentiating a with respect to r, so this becomes 2 pi r. Okay, so it becomes 2 pi r because we are differentiating a with respect to r. Now the next thing we have to do, but what is our radius? Our radius is given as what? 2 centimeter. So therefore, our rate of change of the area with respect to r must be 2 pi multiplied by 2, which gives you 4 pi. And we have to put the units. Area is mentioned in what? So since the radius is given in centimeter here, so area has to be measured in centimeters square per what? And the radius is centimeter. So at the end of the day, you are just going to have what? So this is going to be 4 pi centimeter because you are going to divide centimeter square by centimeter. Area is measured in centimeter square and the radius is in centimeter. Okay, so you are going to have 4 pi centimeter. So that's the rate of change of area with respect to this radius. Okay, which is cm square upon cm. So that's the first example. We are going to look at the next example. I'm quite sure by the time we get to number 3, we must have been able to understand the concept proper. Okay, so let's look at example 2. Example 2 is a bit different from example 1, and that's because the way it is. Okay, and we are going to introduce something new. So pay attention, Kelly. So example 2 says, of course, you can see the question. Let me just read it. A spherical balloon is being inflated and the volume is increasing at a rate of 15 cm cube per second. So the rate, so we are talking of the volume. So what the rate in seconds. So and the units as well should be just a hint for you to know what relationship you need to write. Okay, volume over time, that's what you are seeing there. So it's 15 cm cube per second. At what rate is the radius increasing? So at what rate is the radius increasing? So we are talking of the rate radius over dt. This is what we don't know. When the radius is 10 centimeter. When the radius is 10 centimeter. So we are asked at what rate. Remember, as I told you from the introduction, that when we talk of the rate of change of radius, the rate of change of volume. So we are talking of the volume over the time, okay? Except in the case where we are talking of the volume changes with respect to a radius. That you know is dr over, dv over dr, okay? Now we need dr over dt. How do we calculate that? Okay, the rate of change of the radius. That's what we need. So we say using chain rule, dr over dt is going to be dr. Then now you are now going to introduce something new. But you have to look at what you have here. Now look at this. You have time, you have radius, and you have volume. Okay. So we introduce the volume, which is dv. Then multiply again by the dv over dt now. Okay. So at the end of the day, when you cancel this and this cancel, you are going to have again dr over dt, which is again is on the left hand side. That's the thing about chain rule. Okay, whatever you introduce, you have to write it. So in a sense, when you cancel that, you are still going to have what is on the right is the same as what is on the left here. So dr over dt, and you cancel this and this. Okay, so introduce the volume because we are dealing with volume here. We have volume. We have like 3 different letters, v, t, and r. Okay, so now we have dv over dt, this one, but we don't have dr over dv. So here comes in now the formula, we have to do a relationship. We are talking of a spherical. Okay. So what is the volume of a sphere? So the volume, say but, the volume of a sphere is 4 over 3 pi r cube. So now we are going to relate volume and radius. So we have radius and volume here. So dv, we are now differentiating dv over the r. This equals to, so this becomes 3 multiplied by 4 over 3 pi r square. So this and this cancel. You are going to have 4 pi r square. Okay, so that's what you are going to have. So now you are now going to substitute this into this formula. But one thing you should know here, this is dr over dv, and this is dv over dr. So definitely, if you want to write this one in this form, so it's going to be dr. When we cancel this and this, we have 4 pi r square. Now, look at this. We have dr over dv here, and here we have dv over dr. So if we want to change this one to this form, we say dr over dv is equals to 1 upon dv over dr. Okay, because this becomes this one. So whatever we have for dv over dr has to be, so dr over dv has to be 1 upon 4 pi r square. Okay, so that's just the trick here, because this one you have dr over dv. Okay, but we need, but what we've calculated here is dv over dr, so it's 1 upon dv over dr, because at the end of the day, this one, if you change that, you are going to have just this, because this is 1 divided by, so you are going to have, let me do it here, you are going to have 1 divided by dv over dr, which is same as 1 multiplied by dr over dv. Okay, so at the end of the day, you have this guy. Okay, so now we substitute into the formula. So we have dr over dt equals to, my dr over dv is 1 upon, so this becomes 1 upon 4 pi r square, multiplied by dv over dt is 15. Okay, so now this gives you 15 over 4 pi r square. But we are given the radius. Okay, but the radius is given as 10 centimeter. So we substitute that, you are going to have dr over dt equals to 15 over 4 pi into, that's going to be 10 all square, because the radius is squared. So we have 15 over, this gives you 400 pi. Okay, which of course, if you just use your calculator, you will get your answer. And this answer is going to be, remember you are talking of radius and time, so it's going to be centimeter per sec, which is per second. Okay, so that will be your answer. So let's look at example 3, and the more we go, I think the more we see difficult problems. Okay, so stay with me for the next question. Okay, so let's solve example 3. Example 3 says the side of a cube is increasing at a rate of 6 centimeters per second. Find the rate of increase of volume when the length of the side is 9 centimeters. So again, we are going to use this area. Okay, so we are told the side of a cube, but we have to determine here, we don't know, we can just take a letter to be the side of the cube. Okay, so we can let x represent the cube's side. Okay, so meaning the side s, let's just say s equals to x. Okay, so that's the side of the cube, which is x. The side of the cube, side of cube equals to x. So now the side of the cube is increasing at a rate of 6 centimeters per second. So the meaning, that's going to be dx over dt, rate 6 centimeters per second. Okay, find the rate of increase of volume. So we need dv over dt, which we don't know. When the length of the side, so when x the length of the side, because that's the side, is 9 centimeter. So again, we have dx over dt equals to this, and we need dv over dt. Okay, so say but dv over dt, you always have to write dv here first, then you have to introduce something. Okay, you have x here, so you have xt and v. So you have dx multiplied by dx over dt. Okay, so that's the logic for you to write the correct relationship. So now, do we have dx over dv over dx? No, but we have dx over dt. Dx over dt is given. We don't know this one. So here now we have to apply a formula, a relationship. Okay, we know the volume of a cube. We are talking of x side. The cube is L cube. Okay, times the length times the length times the length. So it's going to be x cube here. So we are now going to differentiate this, which is dv over dx equals, so when you differentiate this, we have 3x square. Okay, so this one comes, we subtract 1. So now we have all the parameters here. So therefore, your dv over dt is equals to, your dv over dx is 3x square multiplied by your dx over dt is given as 6. Okay, so this everything here gives you, this is 18x square, but your x is 9 centimeter. If you plug that in, you have 18 multiplied by 9 square, which is 18 multiplied by 81. Okay, so you use your calculator, dx over, what are we looking for? dv over dt is equals to, so you use your calculator. If you don't have a calculator, what you do always, this you have, so this you can separate this one. This is 18, right, into, this is 80 plus 1. 80 plus 1. Okay, so I have separated this one. Now I can do it simple. So 8 multiplied by this is 64. I have 6, carry 6, put 4, carry 6. 8 times 1, 8, plus the 6 we carry is 14. Okay, so 144, then we add the 0, plus then we have this 18. So just put the 18 here and make your life so easy. This is 8, this is 5, this is 1, and this is 4, and this is 1. Okay, so therefore our dv over dt must equals to 1458. This is volume, centimeters cube per second. Okay, which becomes your solution to the problem. If you don't get it, please look at it again over and over for you to get the understanding. Okay, guys, so let's look at the last column. It says the radius of a circular oil slick is increasing at 1.5 meters per second. Okay, taking pi as 3.14, find two significant figures the rate at which the area of the slide is increasing when its radius is this. So we have data, the radius of a circular oil slick is increasing. So dr over dt is giving us 1.5 meters per sec. Okay, so we have the r over dt because we are talking of radius of a circle increasing at that. Now the next thing, the rate at which we are asked to find the rate at which the area is increasing. So meaning dA over dt, we don't know. Okay, it's increasing when the radius r is 300 meters. So that's it. You've gotten this and you need this one. But remember, so you need dA over dt. What did I say? You write the A here first, then you are going to introduce the new thing here, which is the R, multiplied by the R again over the T. Simple. So you have the R over the T, which is given, and you don't know your A and R. So now you have to draw your relationship that connects area and the radius. And what is that? We are talking of a circle, a circular oil. So the area of a circle is just pi r square. Okay? So now you are going to differentiate dA over dr equals to, this is 2 pi r. Simple as that. So now you are just going to substitute this here. So you have now dA over dt equals to, what is my dA over dr is 2 pi r multiplied by dr over dt is given as 1.5. Okay, so this gives you, this multiplied by this gives you 3 pi r, and remember we are given pi as 3.14 and the radius as 300 meters. Substitute, therefore dA over dt equals to 3 multiplied by 3.14 multiplied again by 300. Okay, so you have 900, this multiplied by this multiplied by 3.14. So this is, you have 900 multiplied by 3.14. So you have 2826. And we are talking of area. The unit here was meters, so it's meters square per second. Okay, 2826 meters per second is the rate of area, which the area is increasing. Okay, the rate at which the area of the site is increasing is 2826 meters square per second. Okay, so if you've been with me so far, please consider to subscribe, share, and if you think you've learned anything so far, please, I just want to emphasize for you to share the video and subscribe to the YouTube channel. Thank you so much, and hope to see you back.